Hi and Assalamualaikum. Introducing myself, my name is Amiratu Nisa, binti Safei from Petroleum Engineering Department under Dr. Ali Sahmi Musa's supervision. Today, I would like to present my final year project research about propane coated with carbon-based nanocomposite as scale in BT carrier and slowly reducing container. Moving on, here is the outline for my presentation, which first and foremost I will start with introduction. Next, literature review, project planning, methodology, result and discussion, conclusion, lastly my recommendations for this project for further research. Firstly, in introduction, scale is a form of inorganic materials deposits that caused by supersaturation at well-pore conditions or commingling of incompatible fluids. Scale will develop when saturated brines from precipitates when its mineral equilibrium concentration exceeds. There are a few factors that cause scale to form, which are when there is an increase in mineral concentration, there are change in temperature, pressure, or pH of the environment, as well as the incompatible waters are mixed together. Scale can build up anywhere from the reservoir up onto the surface. Three processes will take place prior to scale build-up, which are the dissolution of water dissolving ions. Then it's transported along the way until the environment of scale can build up. It starts to deposit. Carbon carbonate, calcium sulfate, barium sulfates are the common types of inorganic scale. Scale can cause light disturbance towards production if it is treated at early stage, but it also can cause well shutdown and stop the production ultimately. This illustration here shows that the condition of scale buildup in a wellbore that can cause well shutdown. Scale also can cause restriction inside the tubing for any intervention activity, also can interfere with running and operation of downhole tools and equipment, for example the LV and SCSSV. It also can cause production capability of the well decrease as the flow area is reduced, also can cause pressure disturbance and fluctuation in wellbore, plugging of the perforation tunnel, fluid is unable to enter the tubing, and ultimately increase the cost to treat the production tubing. In a conventional reservoir, chemical scale inhibitor squeeze treatment is being practiced to prevent the precipitation of scale in the formation and the production line downhole to the surface equipment. This method was used in unfractured well, but nowadays oil and gas have become one of the important elements to many industries, especially in heavy and automobile industries, as well as to the oil and gas industry itself. Oil and gas contribute for a large percentage of the world's energy utilization. This situation leads to an exploration of unconventional reservoir which in need of fracturing. Hence, in fractured well, the previous study and paper analysis come out with new idea of deploying porous propane as scale inhibitor chemical carrier. The porous propane is impregnated with scale inhibitor chemicals and encapsulated. But both of the pre-treatment currently being practiced having their own disadvantage, which the chemical inhibitor in squeeze treatment only effective in part per million. Only 2.5 until 20% out of the total scale inhibitor that has been injected can reach the bottom of the well, giving only in situ release rate. For the impregnated porous propane as scale inhibitor carrier, it has reduced the mechanical strength of normal propane and reduce the functionality of its original propane function. Hence, these are my objectives for this research, which are to develop propanes as scale inhibitor chemicals carrier as to enhance the cost effectiveness of scale treatment by reducing the well downtime, to improvise propanes as slowly releasing container of scale inhibitor chemicals, as to increase the treatment lifetime by using carbon-based nanocomposite coating. This is scope of my research, which are to study current scale inhibitor chemicals treatment delivery technology and fill the gap with this project. Also to investigate the effect of multi-wall carbon nanotubes nanocomposite towards the scale inhibitor chemicals absorption capacity and its releasing time. To run experimental analysis, propane coated with multi-wall carbon nanotubes as scale inhibitor chemicals carrier and add a slowly releasing container. And to verify the usage of multi-wall carbon nanotubes nanocomposite correlate with the scale inhibitor chemicals absorption capacity and its releasing time. Moving on to the comprehensive literature review that has been done for this research. The scope of focus of my literature review will cover about scale pre-treatment technology, propane as scale inhibitor carrier, nanomaterial coating, also resin-coated propane. So, from 19 research papers that have been thoroughly studied, I found the gap and paper limitation for each of the literature review scope. The proposed solution has been made up to fill all the interest gap between the paper and my research. And for the project planning, this project planning has been set up for both continuous semester or final project. All of the Gantt chart, schedule and milestone has been achieved in this project duration. This project is on an experimental basis, so it is significant to set up proper methodology in order to make this research a success. We will start our experimental analysis with study and select the best equipment to use which available in ETP. Next, to prepare the materials and samples, do proper coating process, and scale inhibitor adsorption and desorption tests. And lastly, the result will be analyzed to get the best outcome. This is the equipment that has been selected, which are bromelain pulverizer to grind solid scale inhibitor to size lower than 63 micrometer, a spray gun to create a well-dispersed polyurethane to coat on propane surface, an ultrasonic bath LMTYP T9100H to prepare and disperse nanofluid, and laboratory oven used to dry the solution of solid scale inhibitor uniformly on resin-coated propane, a ZESS VP SEM, which is scanning electron microscope function to analyze nanoparticles distribution after coated on resin-coated propane, a thermogravimetry analysis, which to determine coated propane thermal stability and its fraction of unstable components by concerning the change of weight that occurs as a sample is given heat at a constant weight concentration before and after the nano additive. A flow meter, which is on-built, we use to flow the brine into the coated propane. And lastly, the UV visible spectrophotometer H.DR3900. This equipment used to measure the residual water concentration before and after the nano additive. For the materials preparation, only the best type of materials are chosen, which are the non-porous glass bead, the resin polyurethane, multi-wall carbon nanotubes for nano additive. For the solid scale inhibitor, we use the salt type, phosphonate for liquid scale inhibitor, and the brine that we make it on our own, which is the mixture of sodium chloride, potassium chloride, calcium chloride, and magnesium chloride, and also distilled water. And here we show the description and purpose of this material. In this research experiment, we will execute and get the best result from 4 different samples in comparing the effectiveness when using different types of samples, which are scale inhibitor and examine which compatibility of the scale inhibitor to nano additive. Below are the list of samples that will be prepared. The first sample is the solid scale inhibitor, which is we grind it into the fines below 63 micrometer. Second sample is the solid scale inhibitor solution, which is we mix between the solid scale inhibitor in fine form with distilled water to make a solution. And the third sample is the liquid scale inhibitor, and the last but not least, the fourth sample is liquid scale inhibitor with nano additive. For every type of samples, we have different procedure to coat the propane. But this is the summary of the propane coating process. For first, second, and third samples, we use the type of coating. First, we coat the propine with polyurethane resin by spray to form thin layer of resin. This is to increase mechanical strength and to encapsulate propine as non-fine generated. And the second is impregnated coated propine with scale-inverted chemical. This is to be tested then the absorption and desorption rate of scale-inverted chemical. For the fourth sample, we have the nano additive, so the propane coating process also will be different. First, we coat the propane with polyurethane resin, such like before, by spray to form thin layer of resin to increase mechanical strength and to encapsulate propane as non-fine generated. Second, to coat the resin-coated propane with material carbon nanotubes by soak the resin-coated propane to form spongy surface. This is to increase the absorption and decrease the desorption of scale-inverted chemicals. And lastly, to impregnate coated propane with scale-inverted chemical. So here are the propane coating illustration. This for the fourth sample. It will be the same for the first, second, and third sample, but the first, second, and third sample will not have the nano additive. So the firstly, as we can see here, the glass bead without coating, and the second is glass bead with coating resin, and the third is resin coated glass bead with multi-wall carbon nanotube. You can see the multi-wall carbon nanotubes as the green color, and lastly the absorption of scale inverter towards the coated propane. Here are the real photos for the impregnated propane. The first picture showing the first sample, which are the solid scale inverter in a fine form, and the second sample is the solid scale inverter in solution, and the third sample is liquid scale inverter. The fourth sample is the liquid scale inverter with the nano additive. After the propane has been impregnated, we will run a test, which is the residual test. This is to check and to measure the scale inverted chemical absorption and desorption rate. For scale inverted chemicals to be effective at forbidding the scale to occur, it must be demonstrated at a level higher than the minimum effective concentration, preceding the onset condition that cause scaling. The effectiveness of the scaling inhibitor is measured by analyzing the residual water for the presence of scale inhibitor. Here are the procedure for residual water collection. First, we build a flow meter as per shown in the figure below, and a tube acts as a core feed one sample of fully coated or impregnated glass bead, which is in 4 ml per volume. The core is then installed in a half foot of PVC pipe and closed by end-to-end metal mesh gauze to prevent the glass bead leak off from the core when the flooding takes place. Seal or the possible water leak off, also seal to ensure the brine only flow through the core. The pump and silicone tubes are installed to make a flow meter. This pump is working at 8 ml per minute. The residual water is collected by 4 ml per volume per each sample for 30 vials. And this step for residual water collection is repeated for all types of samples that has been prepared. For the data analysis, the data and results gained from this experiment will be measured and removed, or the data measured will be tabulated. A graph scale inhibitor versus per volume will be plotted to see the emission or desorption profile of the scale inhibitor chemicals from the coated propane. And lastly, the results will be compared and the best outcome will be gained. And here are the three methods of data analysis that has been chosen. First, UV visible spectrophotometer. This is to measure the residual water concentration before and after the nano additive. The second is SEM, scanning electron microscopy. This is to analyze nanoparticles distribution after coated on resin coated propane. And lastly, thermogravimetry analysis. This test and analysis is to determine coated propane thermal stability and its fraction of unstable components by maintaining the change of weight that occurs as a sample is given heat at a constant concentration before and after the nano additive. We will discuss clearly about the results from the experiment executed. then the best outcome will begin and the advance of nano additive usage will be verified. Here are the illustration about how the impregnated propane will work in the reservoir. When the hydrocarbon has been produced, the chemical scale inhibitor will not be released yet because there is no reaction between the hydrocarbon and the chemicals. But when the water efflux also happen, the scale inhibitor chemicals will release when it's on contact with the water. So as you can see here, the orange color represents the hydrocarbon, the blue dot here is the water that coming, and the green color here on the propane is the scale inhibitor with the multiple carbon nanocube that coated the propane. As the water breakthrough happen and it will in contact with the encapsulated propane with the scale inhibitor, and it will release the scale inhibitor slowly. As the green color one, we can see it is the scale inhibitor that has been released. And here we have the control on the release rate, which can extend the treatment time. And as we can see here in the fracturing well, the propane, the white color one is the encapsulated propane with the scale inhibitor. We don't inject the full propane with the encapsulated one, but we put the encapsulated propane with the scale inhibitor with the normal propane, and we pump in the fracturing as a standard fracture job. As we can see here, as the water breaks through, the water will in contact with the encapsulated propane and will release the scale inhibitor, and it will coming into the pipeline. And here are the comparison, the untreated tubing with the treated tubing. The treated tubing is the well that use the encapsulated propane, and the untreated tubing from the beginning the scale will build up and cause a huge problem. Moving on to our data analysis by UV visible spectrophotometer. This test was executed to assess the concentration of scale inhibitor that present in the reservoir water collected. And we take 4 samples, which are solid scale inhibitor fine form, solid scale inhibitor in solution form, liquid scale inhibitor, and lastly is liquid scale inhibitor with a nano additive. A total of 30 vials of residual water were collected for each type of sample, which taken continuously. We put the brine as the baseline reference, and the wavelength parameter is 190 nanometer to 400 nanometer. As we can see here is the absorbent versus wavelength graph, and this is the distributed of each type of sample, which each type of vial for that sample. And this graph is for the solid scale inhibitor in fine form. We can see here the graph, the highest peak of the absorbent can achieve is 3.994, which is the first vial, and it dropped to the 0.319, which is the last vial. And this is the solid scale inhibitor in solution form graph. As we can see here, the peak of the absorbent for the solid scale inhibitor first vial had been dropped to 3.405 compared to previous, and the last vial of the sample also has been dropped to 0.351. And this is for the liquid scale inhibitor. As we can see here, that this graph generates an unstable pattern of the distribution of the first sample until the last sample, because we can see here the highest peak of the absorbent is at the 5th vial, and the last one is at the 24th vial. And this graph is showing the liquid scale inhibitor with nano additive. As we can see here, the distribution of the pattern is more stable compared to the liquid scale inhibitor without the nano additive, which is we can achieve the peak of the absorbent at the first vial, and the last vial showing the lowest of the peak of the absorbent. And we can see here the peak of the absorbent is getting very high compared to previous one, which is 4.419, and the minimum line of the peak of the absorbent only reduced to 1.180. Based on the data analysis from UV visible spectrophotometer for all of the 4 samples, the significance data has been tabulated in this table that has been shown here. And from this table, we can conclude that liquid scale inhibitor with multi-wall carbon nanotube, which is the nanoadditive, is the most effective. This can certify from the maximum line and the minimum line of the sample, also from the distribution of the graph. Based on Bell-Lambert law to interpret absorbent to get the concentration of the chemical from UV visible spectrophotometer data analysis, the law states that the concentration and absorbent of a sample is in linear relation. Thus, if the absorbent is high, the concentration is also high. As you can see here, these are the equations that we use to calculate the concentration of the scale inhibitor that present in the residual water. And here we can see that the C is the concentration, the A is the measure of absorbent that we can get from the graph, the E, absolute E, is the absorption coefficient, and the L is the path line. E and L is considered as constant, which is E is 1 cm, L is 0.05. The C concentration will be calculated based on this equation, and the next data will be tabulated. From the data that has been computed, here are the tables for the concentration of each type of sample. Based on the concentration of scale inhibitor in residual water, for the 4th sample, which is the liquid scale inhibitor with the nano additive, give the highest concentration for both peak of maximum line and the minimum line. This means the absorption of scale inhibitor to resin coated glass bead is increased. From the distribution of liquid scale inhibitor with nano additive graph also showing a more stable pattern, hence the resin coated propan still carries a high concentration of scale inhibitor that can be verified and is also slowly dissolved. From the SAM analysis, as we expect, here in the before picture have slight alternation, which is the necking, could be seen if the coating is not properly placed. The resin coated propans have adhesive and sticky surface, which will provide better particle-to-particle bonding than uncoated beads. Here we can see in the after pictures, and this particle bonding shares the exit stress or overburden stress, which minimize the propan failures and embedment. And in this picture, we can see the nanofibers bridging the polymer matrix. If a well-dispersed nanoscale happen, the fibers with a very high aspect ratio will perform like a bridge that grips the resin matrix to maintain the supplementary mechanical strength. For the TGA analysis, thermogravimetric analysis for the coated propan with the nano additive, it has been assessed that the loss on ignition to be 3.128%. It is very important to maintain a suitable amount of coating of propan, because a less than optimal coating amount may lead a low crash resistance stress level, whereas the integrating pore space will decrease and the mesh size of the finish will increase if the product use excessive coating. So, from this experiment and the result that we can conclude that nano additive have a significant success in propan technology, and as scale inhibitor carrier, also as the slowly releasing container. And if the broad research about the nanoparticles in resin coated propan, this will allow the technology to be applied successfully. and the implementation of propine as scale inhibitor carrier will reduce a large number of costs and expenses in oil and gas industry, moreover in the operating expenditure. Here are some of recommendations from me for this research. Due to the current pandemic that has been spread and the RMO, I have limited source and time to complete this step, which is first, in the further research, we can proceed with the correlate concentration of the scale inhibitor in residual water with the MEC to ensure the effectiveness to avoid scale occur. And the test conducted can be further enhanced by using the real environment of the reservoir, which referring to the pressure and temperature. And the result that gained can be correlated between the experiment results and the real-time period of field with the usage of propans as scale inhibitor carrier, which further can be built accurately. And it will be nice if the simulation of this experiment can be done accordingly by the real case showing the effectiveness of developed propans as scale inhibitor carrier and slowly releasing container with linear additive from the scale build washout. So for the reference, here are the list of the 19 references that has been used for this research. Thank you.